So in this problem, we're going to be asked to find the absolute maximum and minimum values of this function f of xy on this region where x is greater than 0 and x squared plus y squared is less than or equal to 3. So let's first draw a picture of the region that we're interested in. So if this is the x-axis and this is the y-axis, then what I have here is I have a semicircle. This goes out to root 3, this goes out to root 3, and down here we're down to negative root 3. Of course, this is not drawn to scale. Let's imagine that this actually comes in at this point. But this is my region D. Okay, so this is my region that I am optimizing on. And so I need to first find critical points of f and see if they're in this region, and then I'll deal with the boundary. Right, so first let's find critical points. And so to do that, we compute f sub x, which is going to be y squared, and the partial of f with respect to y, which will be 2xy. Okay, so now let's look at the conditions here. So if this is equal to 0 and this is equal to 0, then what this tells me is that y has to be 0. And what this tells me is that x or y is 0. Okay. So now I have to think about what solves this system simultaneously. Well, if x is equal to 0, the second equation is 0, but the first equation is not 0. And so the result of this is that the critical points are of the form x 0, right? Because when y is 0, the first equation is 0, but the second equation is also 0. So anything of the form x 0 is going to be a critical point. So what this means is that the critical points in this picture, the critical points in my region really lie like right along this line segment here. Okay, so these are going to be my critical points, okay, that are on that line that I've sort of bolded in here and circled. And moreover, I can check the value of f at these. So check the value of f, right? This is an absolute maximum problem, so I don't have to worry about the second derivative test. And the absolute, for the absolute max or min, I compute f of x 0. And conveniently, I don't actually need to know what x is because this is just x times 0 squared, which is 0. Okay, so I know that for these critical points all along that line, the value of the function is 0. So now I have to deal with the boundary. Are there sort of interesting points that I have to look at on the boundary? And in this case, the boundary breaks up into two pieces. So I have one piece and two pieces. So on piece 1, what do I have? I have there that x is equal to 0 and y ranges between negative root 3 and root 3. Okay, and here I don't even have to, I mean, I could stick x into my function, etc., and try to find out something, but here it's easy to see that f of 0y is also just always 0. It's just this constant value. So along that whole line on the y-axis, the value of the function is 0. So I don't even have to bother finding the critical points there. The value of the function is just 0. And on the second piece of the boundary, maybe I'll try to make it so that we can see the picture again a little bit. Right? I just get, if I want to break up my equation for the circle into, x equals square root of 3 minus y squared and minus the square root, because I'm restricting to x as being positive, then I only get that positive square root. And so what I have there is that x is equal to the square root of 3 minus y squared. And again, I'm restricting myself to the case where y is ranging from negative square root of 3 to square root of 3. Okay? And so now I substitute in, right? So I get this function, which I'll call g of y. This is going to be f evaluated at the square root of 3 minus y squared, comma y, right? And so what is this? This is y squared. Square root of 3 minus y squared. Okay, and so now I want to do the calc 1 problem where I'm optimizing this function g of y with on this interval negative root 3 to root 3, right? So g prime of y. So this is product rule, so this is 2y square root of 3 minus y squared plus, and then this one I have to do sort of product rule and chain rule, so it's a little bit nasty. So I have 1/2 y squared times 3 minus y squared to the negative 1/2 times negative 2y. And so the result of all of this is that I get, when I add my fraction, so this thing has a negative exponent, so I get a denominator. When I deal with all of the algebra here, what I end up with is 2 times y times 3 minus y squared, all subtracting off a y cubed all over the square root of 3 minus y squared. And so if I want to know when this is equal to 0, right, this is the same thing as saying that 2y. So this is when 2y 3 minus y squared minus y cubed is equal to 0. Right, and now I multiply out, and this is the same thing as saying that I'm going to multiply out and then refractor, so this is the same thing as saying that 3y times 2 minus y squared is equal to 0, and so this tells me that y equals 0 and y equals plus or minus root 2 are the critical points of this function. And so what this means is that we need to check the following points. So we need to check the following points. So we have to check when y is equal to 0. When y is equal to 0, x is equal to root 3. But I've actually already checked all the, so I need, well, here, let me write them down. So I have to check root 3, 0. I have to check when y is plus or minus root 2, I stick that back in. So I have to remember here that x is equal to root 3 minus y squared, right? So when I put plus or minus square root of 2 in here, then I get 3 minus 2, which is 1, so I get 1. So I get 1 root 2, and I got 1 minus root 2, right? And then I get the endpoint. So this is also an endpoint. So this is also an endpoint. And then the other endpoint, I would have y equals negative. Oh, no, sorry. These are not the endpoints. My mistake. I have the wrong square root. I have the wrong square root. So these are the points that I got from here. And then the endpoints are when y is equal to square root of 3. And y is equal to negative square root of 3, right? So these are the endpoints. Right, and so then if I have those endpoints, then what do I get? When y is equal to square root of 3, then x is equal to 0, so I get 0 square root of 3, and I get 0 negative square root of 3, right? So these are the endpoints. And now I want to compute f of all of these. And anytime any component is 0, then I get 0. So I get 0 on all of these. And then on these ones, what do I get? I get 1 times root 2 squared, and so that's 2. Okay. So the conclusion from all of this is that the maximum value is 2, and the minimum value is 0, and that would be your answer. And this minimum value of 0 is occurring at a number of points. It's even occurring at entire line segments. The maximum value at 2 is occurring at exactly 2 points.